as a reminder, when you're working through these, just try to pull out as much information as you can quickly. So again, number 7, what is do you want to do number 7 first or number 8? Which one would you guys like?
Did we do number 5?
Number 5. Any other votes? 1, 5. Okay. Okay. So number 5, what's the first thing that we do?
Degrees of saturation.
Degrees of unsaturation. That is going to be correct. So then we are going to have 18. I get a degree of unsaturation of 1.
Yes.
Yeah, that's what I got.
Okay, so we have a degree of unsaturation of 1. I'm going to give you guys just like a quick minute to figure out this problem. Okay.
I think I figured out most of it, but then I get to the oxygen and I'm like, I don't know what to do.
All right. So I just put the answer on the board so that you can see what it is in case you were working through it. What is the first thing you should think of when you see a degree of unsaturation of 1 and you see some oxygens?
There's gonna be a double bond, or
Probably
like sorry, an ester group.
Maybe an ester, right? Because I have 2 oxygens. So do I could have a carboxylic acid peak, right? Or I could have an alcohol. Do I have either of those? Do I have an OH in this problem? If I scroll down to here, remember carboxylic acid, COOH, would be above 10 and don't have a peak above 10. And alcohol would be a singlet between 3 and 5, and I don't see that. So that means that I do not have an alcohol present or carboxylic acid. So my most likely culprit is going to be the inclusion of an ester. So I know that I'm probably going to have an ester somewhere in my molecule. All right. Now, knowing that, what else can I see here based on the peaks that you see?
You have an isopropyl group.
Yep, I have an isopropyl group. When I have a septuplet next to a doublet, well, with the 1:6 ratio, that means that I'm going to have a isopropyl group of some sort. Where it goes, I don't know. Okay. Now, what type of functional group is this going to be? When I see an integration of 3, what type of group should I think of?
Like the end of like.
Which is no. What's the only functional group that has an integration of 3? Don't overthink it. A CH3, right? It has to be the end of a chain because there's an integration of 3. How many neighbors does that CH3 have? Based on the peaks here.
2.
2. So it's connected most likely to a
CH2.
CH2, right? So CH2. And so now I have this one, and this one as potential candidates, right? So it could be any one of these, but which one of these do you think is going to be my most likely culprit? Did I get those integrations right in the row? I think I did. Now I'm looking at these peak splittings and I'm seeing something just a little bit different. Now, okay, remember how we talked about, I'm sorry, I'm going to clear this real quick. Remember how we talked about what was the worst thing about these types of problems? How many peaks are actually here?
That's a 9. It's a 9.
It's 9. Yep. So what this means is I drew my molecule wrong. Yay! But that's because I didn't read that properly, and that's on me. So that means now I'm going to have my isopropyl group like this. And now it's going to be connected to a CH2. It has to be. That's the only way it can go. So this is going to be that right there, because it has to be. So now when I look at this, I've already accounted for this and I've accounted for that. So this has one neighbor at least. So it's going to be at least a doublet, could be a triplet, could be a quartet. I don't know yet. So it looks like, you know, the CH3, right, is connected to a CH2. Because that's the only thing that's going to give it that triplet splitting pattern. So now, how many neighbors does this have right now?
3.
3, right? So it's going to produce what type of signal right now? A quartet. If there's anything on the other side here, if there's any type of hydrogens, right, it's going to be more than a quartet. Do I have any signal that has more than a quartet?
No.
No, right? I don't have any other signal with the quartet because I don't see, because there can't be anything on that side. So if I have an ester, then that means that that's probably going to be connected to my ester. So what I'm thinking of is that if this is my proton here, these two are going to be B's here. This is C. And I'm going to guess that this is going to be D. This is going to be E. And then there's one more CH2 here. And this is going to be F. So then I just need to connect that to my. So basically I have an ethyl, this ester, and then this chain with 5 carbons in it with an isopropyl at the end. Does that make sense on how we did all of those parts?
Yes.
So the key for all of these is just to sit here and say, what can you pull out? And then try to connect them as best you can. If you get so stuck on a problem, meaning that you are just like, I am completely lost, or I can't connect everything, and I'm just going to go to one of your other problems as an example. zoom out here. Here, I'm going to use this one as an example here. Actually, this one's not a great one for seeing stuff right away, but come on. So, for example, this one here. Can you see any functional groups present in this molecule as drawn? Morgan, what's my degrees of unsaturation for this one?
Is it 4?
Yep. So what should I think I have?
A benzene ring.
Yes. Okay. Now, where do I look in my NMR to see if that's true or not? Between what two
Between
values?
6 and 8.
Do I have peaks between 6 and 8?
Yes.
And what type of benzene ring do I have?
Parasubstituted.
Yep. So I have a parasubstituted ring. So this is what I mean when you just go out and start pulling stuff that you know. Okay. So I have a parasubstituted ring like that. Now, looking at the rest of these peaks, I'm going to have something coming up like this way. I don't know what. And then I'm going to have something coming up this way. So what type of functional group is this going to be? What type of representation?
CH3.
This is going to be a CH3, right?
Yeah.
What about this one?
Same thing.
Okay. And this one?
CH2.
Yep, it's going to be a CH2 probably, right? It's a little above 3, but I don't have anything else that's popping up necessarily in my molecules. So looking at this, yep, I still have an oxygen that I need to worry about, right? So I know that I have an oxygen. Can the oxygen be double bonded? Based on my degrees of unsaturation?
No.
No, because
You only have
I've already
4.
used, yep, so I'm going to have an oxygen like this. So now these are all of my pieces: a benzene ring, an oxygen, a CH2, a CH3, and a CH3, right?
Yeah.
Which of these peaks is probably by itself, meaning that it has no neighboring protons?
The singlet.
Yep, the singlet. So does this
That's
look like
10?
it's connected to the oxygen or to the benzene ring?
To the oxygen.
Remember, you have to be like closer to 4.
Oh, the benzene ring.
So it's going to be attached to my benzene ring. Does that make sense for the rest of you guys?
Mhm.
So if I have my benzene ring like this CH3 is going to have no neighbors, so it is going to be a singlet. All right. Now, I still need to account for an oxygen, a CH2, and a CH3. Based on those patterns, how can you put those together to get those peak splitting patterns? Well, I know my CH3 is going to have to be at the end, right?
Mm-hmm.
Does this CH3 have any neighbors?
Yes.
Because there's peak splitting, right? How many neighbors does it have?
2.
So it's going to have to be connected to the CH2 here, right? That's the only thing left. What is the peak splitting pattern on the CH2? The same thing here.
Quartet.
So how many neighbors does it have?
3.
It's already attached to a methyl, so it already has 3 neighbors. So what's the only thing now it can be connected to on the other side?
The oxygen.
The oxygen, right? So oxygen, CH2 to CH3 like that. Does that make sense? So this is why I say when you are doing these problems, do your degree of unsaturation and then just start pulling out every little thing you can and then just try to connect them. Questions on that? Am I wearing you guys out? Are you guys a little drained right now?
Did you
Okay.
guys already go over 8? I was having a hard time getting back into the Zoom.
We haven't. We can go back over that real quick.
Okay, sorry. Yeah. For some reason, it's saying that the password is incorrect, so now I have to go on my phone. I
Do
don't
you know how this will be applied to in the NMR tests? You said multiple choice, right? Is that what you guys said?
I think that's what she said, that it would be multiple choice.
Yep. So I think you had a problem. I think, was it on this one? No, it might have been this one. Like this type of problem. Here, try to do this one. Which spectrum corresponds to this? Think about what we just talked about. And then, so this is a multiple choice type question. So imagine, if you will, we have this molecule, which one of these? So Maggie, what functional group do you see in there that really sticks out to you? Okay, Morgan, what functional group? Oh,
Isopropyl group.
Okay, so when we have an isopropyl group, how many peaks do we have for the isopropyl group? What are our normal peaks?
We need a doublet with 6 H's, and then a septet with 1 H.
So can I eliminate any of my answers right now based on what you just told me?
Eliminate D.
Yep, we can eliminate D because that does not have a 6 proton doublet, right? Or does it have that? All right, so now we've eliminated that. Okay, so now for our next thing, which on the other side we have a CH3, right? What type of signal should that produce? Does it have any neighboring protons?
No.
So it should be a
singlet.
Can I eliminate A, B, or C based on just that information?
No.
Okay, so I can't eliminate that on that. So now we have here this wonderful little thing that is connected. So on one side, we have this attached to the oxygen. On this side, we have it attached to the carbonyl. Which peak should be further downfield? The septuplet peak?
Yeah.
Okay,
so you can eliminate B.
All right, so now we have A and C. Which one is it most likely going to be?
A.
A, because when we go next to an oxygen, particularly carbonyl, it pulls an ester, it pulls us downfield. So does that make sense how this type of question would be worded?
Yeah.
Okay, so this is really where your tips and tricks come in of basically just trying to pull out what you know about stuff, right? And basically just saying, I know it's there. I can see the functional groups. And which one did you say? 8?
Yeah, just for 8.
Okay, so going through our integrations real quick, and I've got to make this quick because I have to go after this.
Sorry.
No, you're fine. So the first thing we do, and I'm just gonna walk you through this, is we do our degrees of unsaturation, right? So 2 times 12.
24.
Plus 2 is 26. Minus 18 is going to be 8, right?
Yep.
Divided by 2 equals 4. So what should I think?
Benzene ring.
Where do I go to check to see if that's true?
Between 6 and 8.
Right. So now coming down here to look at my peaks, do I have peaks between 6 and 8?
Yes.
What do I know about this structure now, looking at it?
Ooh, there's 2 doublets.
It's a doublet of doublets. It's going to be para-substituted. The integration is going to be 2 to 2. So now using that, this is 2, this is 2, this is 2, this is 2, this is 1, this is 3, this is 6. What else do you see here in the structure?
There's going to be an isopropyl group.
Yep, I have a benzene here that is going to be para-substituted. I don't know what's on either side yet, but I know that that's there. X, Y. I know that this and this are going to combine to form a isopropyl group, right? Now, on the other side, right, I'm going to have what? Oh, did I have an oxygen in this one? I didn't remember what the...
Yeah, we do.
Okay. So I know that I'm going to have an oxygen. Can I have a carbonyl or anything like that?
No.
No.
Nope. So it's probably going to be in the form of what? It's going to be a oxygen that's like this. Do I have an alcohol or anything like that?
No.
Nope, because I don't have like a weird fat singlet, right? Like between 3 and 5.
Yeah.
So I know that I have this oxygen, and then what is this peak with integration of 3 going to be?
That's the
And then-
CH.
A CH3, right?
Yeah.
What is this peak going to be with integration of?
CH2.
It's going to probably be a CH2, right? And then what is this peak going to be here?
CH2.
Yep, it is going to be a CH2. So now when all you have to do is just put these together. So again, in the field of dick moves, we have to take a look at this. How many peaks are here?
Which one? Oh. 7.
There's 9 at the very edge. Again, this is what we call a dick move in the industry. So I'm going to zoom in just to show you guys what I'm talking about. As I scroll up, right? So you can see here at the very left side. So my CH has the isoprop, the 2 methyls to the right. What has to be to the left?
CH2.
Yep. So now I'm going to have a CH2, correct?
Yeah.
So now that I know that I have a CH2, as I kind of scroll back down here, right? Which CH2, do you think is going to be the most likely culprit? This CH2 that's a doublet, or this CH2 that's a triplet or a quartet?
Quartet.
How many neighbors would that CH2 have?
No.
Just one.
I'd only have the one.
So it's probably going to be this. So
Yeah.
now, can I erase all this information real quick?
Yeah.
Okay, so now what this means is that I know that I have this isopropyl on one side, right, with this. So now I have this right here, okay? So then I have a benzene ring that I know that I have.
Mm-hmm.
That is going to be connected on either side. And then I have a CH3, and since it has 2 neighbors, it's going to be connected to a CH2 like that, right? And so the only CH2 left is this one. So what is this most likely connected to?
The oxygen.
The oxygen. So now what my thing is going to be CH3, CH2, oxygen. The oxygen is probably connected to the benzene ring.
Mm-hmm.
And it's connected to this, this, and this. Does that make sense for putting stuff together?
Yeah.
You can say no. That is a perfectly acceptable answer of no, I'm still confused.
It's just, I can like find out what is in it. I just putting it in the right order is where I mess up.
Okay, so obviously that's the tricky part, right? Like that is the part where you guys are running into the mess of it. But
yeah,
was that you, Maggie, who said that, or Morgan? I can't tell who's talking.
it was me, Morgan.
Okay, so Morgan, my isopropyl group, right, is this here and this here, right?
Yes.
So that is a CH connected to a CH3 connected to a CH3 like this, right?
Mm-hmm.
We saw here that this was a non-ed. It has 9 peaks. So how many neighbors does it have?
8.
8. So I have 3, 6. So then this has to be connected to a CH2, correct?
Yeah.
All right. At this point, you may say to yourself, well, I know that this has an integration of 2. This is an integration of 2. This is an integration of 1. This is 3, and this is 6. So I know that it could either be this one or this one, right? Those are the only 2 options that it can be, correct?
Mm-hmm. Yeah.
Okay, if it was this one, how many neighbors would this one have to have?
3.
Right, so then it would be,
Oh, but I can only have, okay.
it'd have 1, but this is really far downfield, right? So this is probably the one that's attached to my oxygen or whatever, right? So this is probably not correct.
Yeah, okay.
So it's just a matter of going through and then just eliminating stuff as best as possible. Tomorrow, I am not doing anything. It is a mock AP day for my students, so I don't have to do anything. Would you guys like me to meet tomorrow during the day?
Can you?
I can. I'm free most of the day tomorrow.
Yes.
What
It's
time,
helpful to just like watch you go through it.
what time would you guys like to meet tomorrow?
Whatever is good for you.
It's up to you. Like I'm 3 hours ahead, so like my day is like I'm probably up well before you guys are. Plus I'm an old
Well,
man.
our test is at 12:30 Arizona time.
Yeah, my test is at 11:10 for my section.
So what time would you guys again tell me what time would you guys like to meet? I can't.
Could
Okay.
9 o'clock work?
Yeah, 9 would work.
Okay. Because I think that'll work for like both sections because
All right.
I know
Well, I
they-
mean, if you come later, I'll just keep working through it because I don't have to do anything tomorrow.
okay.
All right. So just remember NMR, it's a logic puzzle, right? Just think about how many peaks, that tells you how many neighbors there are. Think about things like, is it a para-substituted benzene ring? Is it monosubstituted? Do I have an isopropyl? Do I have a terbutyl? What's my degrees of unsaturation? And then just try to combine your pieces together that makes sense, right? So don't stress too much. And then for IR, just look for whatever functional groups you can, get in, get out, bam, you're done. All right. I will see you guys tomorrow at 9 a.m. Good luck to you studying, and I'll see you tomorrow. Everyone have a good evening.
Thank you too.
You're welcome.
Yeah, have a good night.
Night.
Sorry I was late, but I'll see you tomorrow.
That's okay, Alyssa. You're dead to me now.
Oh my god. It was nice seeing you too.
Later,
Okay.
Matthew. Bye, guys.